question 2 clearly looks like a further calculus question because we've got an integral, which is a slightly more complicated function than what we're used to. For example, the 3 over 2 here, it's very hard to break that bracket out, so we're best using our kind of reverse chain rule. If we have something along the lines of, x squared plus x to the negative 1 plus a half x, yeah, we can just integrate that, that's okay. Even if we've got something like, x cubed plus 2x squared plus 3, all over x, we can break that apart, so I could call that x cubed over x plus 2x squared over x plus 3 over x, start cancelling out the x's, to give me, x squared plus 2x plus 3x to the negative 1, and just integrate each bit in turn. That would be okay, I could do that. But when we've got a bracket, if we've got an easy bracket like this, I could just break it out, that's fine. But when we've got fractions or big numbers, it's easier to use our rule. Okay, so that's your clue that you're using your composite, your further calculus rules. So first thing I want to do is I'm going to set this up now. Write your integral sign and write your dx just to remind you. Okay. Now, I always say when you cross the line, you change the sign, so that becomes x plus 5. Let's see if that writes an x. There we go. Plus 5 to the negative 3 over 2. Right, and that's me ready to integrate. The next thing I would do is just on the side of the page remind myself what I'm doing when I integrate. So before, I said that y was x cubed, so dy by dx is 3x squared. So if you want to go back the way, that's you integrating. So how do you get from here to here? Well, you add 1 on to the power and divide by the new power. Okay, so add 1 on and divide by the new power, just to remind you, what's going on. So if I do that, if I add 1 on to the power, negative 3 halves. If I add 1, now 1 is 2 halves, that'll give me negative a half. So I've added 1 on, and then I'm going to divide by the new power. Very good. Now the 6 stays where it is. I'm going to write that in green just to remind us that stays where it is. That's fine. Okay, but our extra rule is that we have to multiply through by the divide by the differential of the bracket, which in this case actually, if I differentiate my bracket, I just get 1. So I'm just going to put a times 1 down here. Okay, that's me dividing by the differential of the bracket. Okay, and don't forget that whenever I do this as well, plus c. So remember your dx. If you want to, you could write that right away, but just remember that you're going to have your plus c after you integrate. Okay, so we're nearly there. We just need to tidy this up a little bit. So this is negative a half. So 6 divided by negative a half. I'll do that on the side, I think, over here. So if I do 6 divided by negative a half, that's the same as KFC, where you keep flip change. So that's negative 12, isn't it? So I'm going to end up with, I'll keep this in green actually, so negative 12. The bracket stays where it is at x plus 5 to the negative a half, and the plus c also stays where it is. So not bad for 3 marks really. Like I said, this is very similar all the way through. Yeah, just watch out for this question. You didn't have to do anything, but I think it would be worth showing it anyway. But you would have to divide by the differential. So this one, there were actually, I think maybe some people would have forgotten to do it and got away with it. But yeah, you're getting a mark for this first bit where you're doing the setup. You're getting a mark for laying out like this, and then you get your final mark just for tidying up as well. So yeah, 3 marks in. Now, I'm just chatting around the side here. It's worth thinking about these things as well. That is definitely something that people seem to struggle with, and they see this, they get all confused. So remember, you can split it up, and remember you're using this when you've got your bracket with a large power or a fractional power. Okay, so yeah, question 2 done.